Greetings and salutations. I'm Mr. French, and I'll be your virtual teacher for this lesson. This is Algebra 1, Lesson 9.5, basically solving quadratic equations using the quadratic formula. All right, let's get some learning. So 9.5, shorter version of the title of the lesson would be the quadratic formula. This is a very handy tool that can allow you to solve any quadratic equation. Whether the equation can be factored or cannot be factored, this will allow you to get to the answer just by identifying what a, b, and c are in the ax squared plus bx plus c equals 0, and then plugging them in and doing some simplifying. And it's the method that some algebra students just end up preferring to go to. Some prefer to check. Personally, this is what I do as well. I check first to see, is it factorable? And if it doesn't look like it's factorable, then I jump to this as the way to do it. I want to briefly step through how we get the formula. Now, this is just extra background stuff. This is not something that you're going to have to be able to do. One thing that you haven't seen much in math yet, but that the higher up you go in math, it becomes more and more of a thing. A little bit in Algebra 2, maybe more in pre-calculus and definitely calculus and beyond, it's just kind of assumed that you rarely, if ever, are given an equation to use without being shown how we got the equation, without being shown where the equation comes from, without kind of justifying that the equation is a valid equation. Sometimes you might have to know how to derive the equation. Sometimes you might not. Here, you're not going to have to know how to do this, but I just wanted to start with taking a look at that before we jump into practicing using the quadratic formula. So if we start with our ax squared plus bx plus c equals 0, and we wanted to solve this we wanted to solve for x using completing the square. Okay, well, first what we did with completing the square is we threw c to the other side. So that would give us ax squared plus bx equals negative c. Then we also said, oh, the way that we do completing the square, it works if we have a 1x squared. And here a might be 1, it might be something else. So to ensure that we have a 1x squared, we could divide everything by a. So if we did that, we would get x squared plus b over a x equals negative c over a. Divided this by a, divided this by a, divided this by a. All right, now for completing the square, what we did is we took this coefficient of x, we took this, divided it by 2, and then squared it. And we added that to both sides. So if we took this and divided it by 2, I could show it as if we're dividing the whole thing by 2. But if we played around with the fraction a little bit more, we would see that dividing by 2 like that is the same thing as dividing by 2 like that. And so that's how we'll write this. So what we'll do is we'll take our x squared plus b over a x plus b over 2a squared equals negative c over a plus b over 2a squared. Okay, so what we've done here is we have the pattern that is correct for having a perfect square. And so we can take these three terms and distill them down to being x plus this part that we're squaring plus b over 2a. And it's that whole thing squared. Equals, well, let's see what we can do to simplify things a little bit. So I could say we have a negative c over a, and if I square this, I get a b squared plus b squared, and here I get a 4, because 2 squared is 4a squared. So 4a squared over 4a squared. Okay, Now I want to combine this into one fraction. It's just going to look a little bit nicer if I can combine this into one fraction. So in order to do that, what am I going to have to do? Well, let's see. I have a 4a squared here, right? In my denominator. So I can't add that to this. I can't add these fractions yet because the denominators don't match. To get this denominator to match that denominator, I'm going to have to multiply this fraction by 4a over 4a. So if I multiply this by 4a over 4a, and I can do that because 4a over 4a is 1, so I'm not actually changing that value, I'm just changing what it looks like. Then my right-hand side becomes a negative 4ac. I'll go ahead and put stuff in alphabetical order here. I have 4ac over 4a squared. And I still have my plus b squared over 4a squared. Now I can combine these into one fraction. And I'll go ahead and pull this around. So this is still my x plus b over 2a squared. Okay. Now if I'm going to do two things at once here because I'm running short on space. I'm going to take the square root of both sides, but first I'm going to get this into one fraction. And when I combine these, rather than having a negative term plus a term, I'm going to put the positive term first. So I'm going to say we have b squared minus 4ac, that's what I have on top, over 4a squared. Now here, if I take the square root of both sides, I get x plus b over 2a. And I'm taking the square root of both sides. Now, I had a variable squared, which always makes it so x could be positive or negative, and when you square it, you'll get, there are two different ways to get this, by plugging in some positive value, squaring it, and getting this, or plugging some negative value in, squaring it, and getting this. So that's, again, why when I take the square root here, I have to do plus or minus. And let's look at what we can simplify. So I have this big square root with this whole fraction on the inside. Now I look at what's on the bottom, and I have a 4 inside the square root. Well, the square root of 4 is 2. I also have an a squared inside the square root. Well, the a squared square root of that is a. So my denominator here, that is a 4a squared inside the radical, inside the square root sign, can become a 2a outside the square root sign. So then what that gives me here is this gives me a plus or minus the square root of b squared minus 4ac, and then my denominator is 2a outside the square root. Now I haven't done this yet, but I need to, in order to finish solving for x here, I need to subtract both sides from both sides, b over 2a. Now notice I have a 2a on the bottom here and a 2a on the bottom here. So what we can do is we can combine, when we do minus b over 2a on both sides, I can put this along with this fraction, and my minus b I can put there, and my over 2a, when you add or subtract two fractions that have the same denominator, they can combine into one fraction. That's what I've done there, and I'm left with just the x, and that is the quadratic formula. In other words, if you write a quadratic equation in standard form, so you have a x squared plus bx plus c, you can find what equals 0. You can find what values of x you can plug in to solve this equation by identifying what a, b, and c are and plugging them in here as where you're supposed to. So whatever a is, plug it in there and there. Whatever b is, plug it in there and there. Whatever c is, plug it in there. Do however much simplifying you can, and that will tell you x. And we get the number of answers that we should for however many solutions there are. Because recall with these, there can be no real solutions. And we looked at a graph That would be like if your parabola never crosses the x-axis, you'd have no real solutions. What will happen there is what's inside the square root here, you'll get a negative number inside the square root. And at this level, we just say no real solutions if you get a negative inside the square root. Or it could be you have one real double root, and that's where it touches the x-axis, just one place. And what's going to happen there is whatever the b squared minus 4ac, that's called the discriminant. We'll deal with that. You'll get more into that a little bit in Algebra 2 and then pre-calculus. If the discriminant, b squared minus 4ac, if that's 0, when you take the square root of 0, that whole thing becomes nothing. And so you have plus or minus 0, which doesn't make any difference. And so you're just left with negative b over 2a. And you might have seen that negative b over 2a before. Negative b over 2a was the equation that we had for finding where the axis of symmetry is. So if the discriminant becomes 0, you have plus or minus square root of 0, which is nothing. You're just left with, oh, the axis of symmetry, negative b over 2a, is where our root is. And you have negative b over 2a plus 0, negative b over 2a minus 0. You have your double root, your one double root, where the root, in other words, where the parabola touches or crosses the x-axis, is in the same location as the axis of symmetry. And then the other possibility we can have here is where your parabola crosses the x-axis in two different places, and that will happen when the square root is a positive number inside of here. So you have plus or minus some value. So what we end up with, if you view this as two separate fractions, you have your negative b over 2a plus or minus square root of b squared minus 4ac over 2a. The kind of what we have going on here is the negative b over 2a, that's where the axis of symmetry is. And then this plus or minus square root of b squared minus 4ac over 2a, that's how far to add, that's the distance to add to get to this root, this place where it's crossing the x-axis, how much to add from the axis of symmetry to get there, and how much to subtract from the axis of symmetry to get there. But whether or not you view it like that, this equation, when you do the plus whatever and the minus whatever, that will give you the two different places where the parabola crosses the x-axis. All right, so this is the formula. In some shape or form, you'll need to memorize it. I know there are different tunes, song tunes that some people memorize it to. I think one's like negative b, plus or minus. I forget which tune and everything like that. One of these days I'll look into that a little bit more, but I've just, memorize and do however much I needed to way back in the day, whenever that was, in order to just kind of pound the pattern into my head. So let's do a couple sample problems. Let's do one like this. Example. Solve. And we're going to solve x squared minus 2x minus 15. X squared minus 2x minus 15 equals 0. So first I'd ask myself, is this in standard form? Is this in standard form? Do I have x squared chunk, then the x chunk, then the constant equals 0? Yes. Okay, cool. Next, I would recommend list what a, b, and c are. A is the coefficient of my x squared term, so a is 1. B is negative 2. That's the coefficient of the x term, negative 2. C is negative 15. Okay, so then I would write my equation. X equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a equals, now I'm going to plug in what I know. A negative 2 is positive 2 plus or minus the square root of negative 2 squared. Make sure to put that in parentheses, because if you don't put that in parentheses, you are squaring a 2 and making it negative, which will give you negative 4. Here we're squaring a negative 2. Minus 4 times a, what's a? A is 1. What's c? C is negative 15. That's inside the square root. And all of that over 2 times a, which is 1. So then I would take my calculator and let's see what we get inside of here. So I know that the -2 squared is 4, right? So that'll give me equals 2 plus or minus the square root of 4. Let's see what this is. Becomes minus, and I have positive times a positive times a negative. So positive times a positive times a negative will give me a negative number. I'm subtracting a negative number, so it's going to become plus 4 times 15. Well, 15 times 2 is 30. Double that, we have 60. All of that over 2. 2 times 1 is 2. So this becomes square root of 64. Ooh, that's nice. Square root of 64 gives me a nice, because 64 is a perfect square, so square root of 64 is 8. So what I have here is 2 plus or minus 8 over 2. Now let's see what that becomes. I'm going to get two different answers here. 2 plus 8 is 10. 10 halves is 5. 2 minus 8 is -6. -6 on top over 2 gives me -3. Those are my two answers. X can be 5 and it'll solve the equation, or X can be -3 and it'll solve the equation. Or in other words, when we graph this parabola, the two places where it crosses the x-axis, it crosses the x-axis at -3, we'll say somewhere in there, cross the x-axis at 5, somewhere out here. Okay? All right, so sometimes you get nice integer answers when you plug in the values and simplify. Sometimes rather than integers, you might get fractions. Let's look at one like that. We don't need to do any further work approximating our answer there because we got exact values that we're dealing with there. So let's try one, maybe like this. Not erasing very well. All right, there we go. Let's go example. Solve. What am I solving here? I'm solving. Let's do 10x squared. 10x squared minus 31x equals -15. All right. Interesting, we have a 15 in common. Other than that, everything else is different. So first, we have to check, is this in standard form? And not quite yet, because standard form has the x squared term, then the x term, then the constant equals 0. So we got to put this in standard form first. 10x squared minus 31x plus 15 equals 0. Now I'm in standard form. Now I can list what A, B, and C are. A is 10, B is -31, C is 15. Okay, my equation, x equals -b plus or minus the square root of b squared minus 4ac, all of that over 2a, and let's plug in what we know. Negative b is -31, that gives me a positive 31, plus or minus the square root of -31 squared minus 4 times a, which is 10, times c, which is 15. All of that over 2a, a is 10, so 2 times 10. Okay, we got some big numbers going on. Also, I don't know about you, but I wouldn't want to have to try to solve that using factoring. You could, this one could be factored. It would be you'd find what, if we move that 15 over, you'd find what 10 times 15 is, so 150. You'd be looking for two numbers that multiply to be 150 and add to be -31. Whatever two numbers are there, you'd use those two numbers to split your -31x into two separate terms. Now you have 4 terms, and you do factoring by grouping. First 2 chunks, second 2 chunks, and go from there. And you would get something. But yeah, either way, you're dealing with some ugly numbers, but quadratic formula, again, is a very handy tool. Okay, let's see what we start to get. 31 plus or minus. -31 squared is going to be the same thing as a positive 31 squared. So I'm just going to do 31 squared, and that's 961. 961 minus, let's see, 4 times 10 is 40. Well, I know 4 times 15 is 60, right? Because 15, 30, 15 times 2 is 30, times 2 again is 60. So this is minus 600. All of that over 20, 2 times 10 is 20. So 961 minus 600, that is 361. 31 plus or minus square root of 361. Let's see if that gives me a nice number. Ooh, square root of 361 is 19. So this gives me plus or minus 19 over 20, which that is, and I usually like to do my minus first because that gives me my smaller value and then my bigger value. We talked about that briefly in lesson 4. So what I have going on here is I have 31 minus 19 over 20, and I have 31 plus 19 over 20. Now if I do 31 minus 19, I get 12. So this is 12 20ths, and both those are divisible by 2, so I can reduce. So if I divide by 2 and divide by 2, 12 over 2 is 6, 10 over 2 is, sorry, 20 over 2 is 10. That's the same thing as 6/10, and I can divide by 2 again and get 3/5. 3/5. That doesn't reduce any further. That's one of my answers. And then let's see what happens here. 31 plus 19 is 50. So I have 50 over 20. Well, I can divide both the top and the bottom by 10, and that just gives me 5 halves. So those are my two answers. 3/5, which should be what, 0.6, 0.6, and then 5 halves, 2.5, 2.5. So again, these are the two values that when plugged into the equation solve it, or if you're thinking of it like a graph, these are the two places where the parabola crosses the x-axis. It crosses the x-axis at 0.6 and crosses again at 2.5. All right, so this one was solved to be two integers. This one solved to be two fractions. Let's look at what it'll look like if, when you solve, you cannot simplify the square root. Or at least you're left with a square root as part of the answer and how that will come out. Let's do one more sample problem. And that should just about do it for this lesson. Okay, so we have, let's solve negative 3x squared equals 8x minus 12. Negative 3x squared equals 8x minus 12. All right, first question, am I in standard form? And no, I'm not in standard form yet. But if I throw this negative 3x to the other side, to the right-hand side, I get a positive 3x. So that would give me a positive 3x plus 8x minus 12 on the right-hand side. But if I just swap the right-hand side with the left-hand side, that would give me an equals 0. Because I would have 0 equals 3x squared plus 8x minus 12, 3x squared plus 8x minus 12 equals 0. I just took the right-hand side and the left-hand side and just did a flippity-flop. Now I'm in standard form. I can list what I know, A, B, and C. A is 3, B is 8, C is negative 12. Okay, my quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Look at what I know. I have negative 8 plus or minus the square root of 8 squared. I don't need parentheses because it's a positive number. 8 squared minus 4a, which is 3, minus 4 times 3, times negative 12. All of that over 2a, or 2 times 3. Okay, let's see what we get. Negative 8 plus or minus the square root of, and let's see what we get here. 8 squared is 64. So I have 64. I have two negatives there, so it's going to become plus. Plus 4 times 3 times 12 gives me 208. 208 inside the square root over 6. All right, well, let's see what we can do here. For trying to reduce these, we haven't formally dealt with simplifying radicals yet. So if you needed to stop here and then use your calculator to get the two decimal approximations, that's okay. If you can reduce it further, that would be great. What I like to do first, I like to see if 208 is divisible by 4. It is. 208. So let me do that. You can see this over here. Square root of 208 is the same thing as square root of 4 times 52. Now what's the square root of 4? Square root of 4 is 2, so this becomes 2 times the square root of 52. Now let's see if 52 is divisible by 4. Ooh, it is. You could, so I'm checking 4 because it's an even number. If or an odd number, I might be trying, is it divisible by 9? If it's divisible by 9, I could rewrite this as 9 times whatever, in which case the square root of 9 is 3, and a 3 would come out front. But the same thing as 2 times the square root of 4 times 13. Well, the square root of 4 is another 2, so that's the same thing as 2 times 2 times the square root of 13. 2 times 2 is 4, so 4 square root of 13. 13 is not a perfect square, so that's just stuck as is. So what I have going on here is I have negative 8 plus or minus 4 root 13, all of that over 6. All right, well, let's see if this can simplify further, because each of these terms I can divide by 2. So if I do negative 8 divided by 2, I get negative 4, plus or minus, if I do 4 divided by 2, I get 2, square root of 13, all of that over 6 divided by 2 is 3. That is as far as that can go. It's ugly, I know, but this is a nice compact way of representing the two exact values, because the square root of 13, if you tried to figure out what that is, it's a decimal number. It would be a number where the decimal values keep going on forever. So there's no way to write the square root of 13 without some kind of rounding, unless you write it as just the square root of 13. And there are other ways using like fractional exponents and stuff like that, but yeah, this is a decimal that keeps going on forever, so we have to write it in some shape or form that's representing this is just the square root of 13. But we can use our calculator to approximate. We can use our calculator to approximate what is square root of, or negative 4 minus 2 root 13, all of that over 3, and what approximately is the square root of 4 plus 2 root 13, all of that over 3. So I'm going to go negative 4 minus 2 times square root of 13. Oops, delete 13. Enter. I'm going to go, once I've hit enter, I have what the entire top here equals, and then divide it by 3. And I get this is approximately negative 3.7. Negative 3.7. This approximately, it's like an equal sign. I think we talked about this last lesson. It's like a squiggly equal sign. It means this isn't exactly equal to, it means this approximately equal to. And then I can do the same thing with here. I'm going to go negative 4 plus 2 times the square root of 13 equals, get that? All of that divided by 3, and I get 1.1. So approximately 1.1. So roughly negative 3.7 and 1.1 are the two values that will solve the equation. So homework-wise, you'll have some of these where you need to, let me get out of the way of that, just in case you finish jotting any of that down. You'll have some where you need to use the quadratic equation to solve, just like we've been doing. And then you have some also where you will calculate, oh, okay, yeah, you do have to do that, where you calculate the value of the discriminant. The discriminant, just to make sure you have that in your notes. We talked about it briefly, but let's get this down on paper for you. You have a nice little reference area. The discriminant is b squared minus 4ac. The discriminant is the part of the quadratic equation that is inside the square root. Okay? We have square root of, or sorry, b squared minus 4ac. That's the discriminant. We could say if b squared minus 4ac is greater than 0. If you solve this, you get something that's supposed to be just greater than, not greater than, or equal to. Greater than 0, what you have is two distinct real roots. Two distinct real roots. If b squared minus 4ac equals 0, then you have one real double root. If b squared minus 4ac is less than 0, so you have a negative number inside the square root, then you have no real roots. What's going on there is you have two imaginary roots. All right, we talked about that earlier and we looked at the graph of it. So I'm not going to spend time talking about like graphically what's going on. Yeah, because we talked about that already. But there you go, nice little section of your notes for that section of the homework. And then the third section of the homework says use factoring, completing the square, or the quadratic formula to solve each quadratic equation. That's numbers 11, 12, 13, and 14. And what I like to do is I like to look at it first and I see, does this look like something I can easily factor? If I can easily factor it, I'm going to go that direction. If it doesn't look very easy to factor, then usually I go to the quadratic formula. Completing the square can work, but it's usually the third thing on my list for what I would try. All right, that should get you well set up for rounding out this portion of the chapter. Hope it goes well, and as always, let me know if you have any questions. I'm happy to help, whether it be checking answers or looking at your work because something doesn't quite seem right, or re-explaining something. So one of the downsides to doing these as videos instead of being live in class is I explain things the way that I explained them here, but I don't know if some of you would have had like, oh, Mr. French, can you explain that a different way? That doesn't quite make sense. Or can you review that again, re-explain, something like that, because I know that sometimes just a slightly different way of presenting something can work well for some people. But hopefully you're able to track with this okay. And yep, I'm available if you have questions. Thanks.